The second problem that we're supposed to do is y equals 3x squared plus 4x minus 8. Now, again, we're supposed to figure out, does the parabola open upward or downward for part A? And again, to do that, we look at the leading coefficient, and to do that, we have to make sure that this is in standard form. This is in descending order of powers, so we have it exactly the way we're supposed to. Now, I look at the leading coefficient. That's the 3. That's positive. Since it's positive, I know that this is opening upward. So that's not too bad. Part B, we're supposed to find the vertex. Once again, the vertex happens where x is equal to negative b over 2a. And as always, we have to make sure that this is in standard form. It's in standard form, so we write a, which is 3, b, which is 4, and c, which is negative 8. So we don't care about c, we just care about a and b. X is equal to negative 4 over 2 times 3. So this gives me that x is equal to negative 2/3, and this gives me that x is negative 2/3. Now, this is the x coordinate. I need to find both an x and a y coordinate. So I know that I have negative 2/3 over here. And then I have that, and then what I'm going to do is I'm going to plug that back into my original equation, y equals 3x squared plus 4x minus 8. I'm going to substitute in this guy right here, and I get y equals 3 times negative 2/3 squared. I'm going to square this entire thing, and then I'm going to multiply by 3. Remember your order of operations. 4 times negative 2/3 minus 8. And this will give me y is equal to 3 times negative 4 over, if I multiply a negative times a negative, I get a positive, and then if I square 2/3, I get 4/9 plus 4 times negative 2/3 is negative 8 over 3 minus 8. Then if I continue on, I get y equals 4 over 3 plus, and I could actually say minus now, minus 8/3 minus 8. That gives me negative, 8/3, positive 8/3 minus 8. And what am I doing? I'm messing up left and right here. Negative 4/3 plus 8. And then if I subtract those from each other, I get negative 9 and 1/3. Or if I write this as an improper fraction, I get negative 28 over 3, which in the end, I need to write this as an ordered pair. I have my first number right there, my first coordinate, negative 2/3, and I have negative 28 over 3. Again, not two different answers, but one single point made up of an x coordinate and a y coordinate. For part C, we find the discriminant. The discriminant, once again, b squared minus 4ac. I have a, b, and c already. A is 3, b is 4, c is negative 8. So I have 4 squared minus 4 times 3 times negative 8. That will give me 16 minus, that turns into a plus. Negative times a negative is a positive. 4 times 3 times 8. That's going to give me 96, and then if I add those two, I get 112. So my discriminant, if I call this D, my discriminant is 112. For part D, I'm just concerned with D and its relationship with 0. Again, D is positive, just like it was in number 1. So since D is positive, that tells me that I have 2 solutions. For part E, we're supposed to figure out how many solutions we actually have. Or I'm sorry, whether the solutions are rational or irrational. And since 112 is not a perfect square, that means that what we have is irrational. So we're not going to be able to have one nice pretty number, a couple nice pretty numbers for this. Part F, we're supposed to solve this using the quadratic formula. Now this is the really tricky part of this problem. This is what makes this particular problem hard. So let me write that down again. Y equals 3x squared plus 4x minus 8, and I write down that A is 3, B is 4, and C is negative 8. Now, if I want to solve this for 0, if I want to know the zeros, I'm going to use the quadratic formula. So x is 0 when y is 0 when x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. If I substitute all that in, I get x is equal to negative 4 plus or minus square root of 4 squared minus, I should be putting parentheses around all these, minus 4 times 3 times negative 8. That's all over 2 times a. X is equal to negative 4 plus or minus. From part C, we found out that the determinant was 112. So we have the square root of 112 over 6. And we're not done yet. I know a lot of people are probably tempted to leave it like this. We're not finished. The reason that is, this has a perfect square in it. It's divisible by 4. It's also divisible by 16. This will give us 16 times 7 over 6. Negative 4 plus or minus. If I just have multiplication and division inside of this, I can split it apart into 2 separate radicals over 6. X is equal to negative 4 plus or minus, this is 4, square root of 7, over 6. Now, this looks like it would be tempting to leave it like this. If this negative 4, this 4 root 7, and the 6 didn't share a common factor being 2, then we could leave it like that. However, each of them is divisible by 2, so I'm using distributive property. I'm multiplying everything by 1/2. So if I multiply this first one by 1/2, I get a negative 2 plus or minus, so I'm pulling out a 2 from each of these. Multiply this by 1/2 and I get 2 root 7, and then multiply 6 by 1/2 and I get 3. And this, finally, is my final answer. I'm looking for an exact answer here, so I'm not going to approximate this. Now, you may have noticed earlier I made a mistake here. I didn't do this part correctly. This should be, what did we come up with? We should have come up with negative 2/3 and negative 28/3. Negative 2/3 and negative 28/3. Hopefully that's the last mistake that I'll be making on this.